My experience with YR was really good. I won't even lie about it. It was able to keep up with my schedule. It didn't interfere too much. So I would say really good. My name is Melissa Nnam, and I'm an intern at the YRI Fellowship. This is my science fair presentation, the Explainable Anemia Severity Screening Tool using CBC features. The aim of the project here is to construct an intelligent machine learning screening system that utilizes the standard complete blood count results to categorize patients into 4 distinct anemia severity tiers. The core goal is to demonstrate that machine learning can achieve near perfect classification while maintaining transparency and explainability, using non-expert users, ensuring non-expert users understand the key blood parameters driving each assessment. So this is the background. Using a complete blood count provides vital quantitative data regarding blood composition. Key features evaluated in this project include hemoglobin, the primary oxygen carrying protein, red blood cell count and PCV, cell concentration, and packed volume percentage. Red cell indices, MCV, MCH, MCHC, and RDW, leukocytes and platelets, immune cell, and clotting counts. Project's anemia screening categories. So as you can see in this table, these are the different anemia severities. These are all the levels you have to do to get this. For no anemia screening, you have to have a hemoglobin greater than or equal to 13. Mild anemia, you would have to have a hemoglobin level of less than 13 but greater than or equal to 11. Anything less than 11 but greater than or equal to 8 is moderate anemia. And anything under 8 in hemoglobin levels is severe anemia, which is like really low. We have data set and machine learning models. Our original data set was 374 records. After we cleaned it up a bit, we had 364. For the distribution, around 35% of the people in the dataset had no anemia, 34% had mild anemia, and 25% had moderate, and only 4% had severe anemia. And the train test was 291 training instances, which is 80%, and 73 test instances. And here are the algorithms or machine learning models we used for this project. We used logistic regression, and we also used random forest classifier. When we were using the project, we took account of the accuracy of both of the models. Logistic regression had a severely lesser accuracy compared to random forest, as you can see here. This proves that random forest is like the better model we should be using in this case. These are the top CBC features according to random forest. Hemoglobin is the first one. Packed cell volume is the second, and RBC count, red blood cell count, is the third. MCH, MCV, MCH, MCHC, and RDW take less than 0.14% and barely affects the CBC features. The top 3 predictors identified by random forest also directly correspond to physiological markers in clinical hematology, borderline disability, and error analysis. For the borderline testing results, we have moderate anemia with a 10.8, which is correct, and a 73% confidence. And for mild anemia, we have 11.0 in hemoglobin levels for mild, which is also correct, with a 51% confidence. Confusion matrix insights. High precision correctly classified 72 out of 73 samples. Single misclassification. One severe anemia record was classified as moderate anemia. Most likely the case for this is as severe anemia doesn't really happen that much. So we would obviously have more moderate anemia cases than severe anemia. So that might cause it to think that, hey, this is moderate anemia instead of severe anemia. As you can see, they only had 16 records in total, which kind of also caused that too. Explainable AI output source. So this is moderate anemia. So let's see one of the output sources. We have a prediction for moderate anemia. The clinical purpose provides direct screening tier estimation. The main reason they estimated moderate anemia is because the hemoglobin level was greater than 11. Supporting info is low packed cell volume. Additional info is MCV with normative range. Safety message. Educational result. Consult a medical professional. Key project conclusions. Random forest achieved 98.6%, demonstrating the capability of machine learning in automated anemia severity screening. Model interpretability. Feature importance rankings and structured output explanations ensure transparent predictions for screening decision support. Boundary insights. Confidence score drops off near threshold cutoffs, as we saw in previous slides, and accurately reflect physiologically uncertainty at clinical category boundaries. The limitations and safety guidelines. Data size and imbalance. Limited to 364 records with only 16 severe anemia cases, require expanded dataset validation in future work. Encoded demographics. Sex variable was stored numerically. 0 without clear documentation, preventing demographic subgroup analysis. Project-specific cutoffs. Hemoglobin ranges were established for educational screening and should not be treated as universal medical guidelines. Educational and screening scope. Intended solely as an educational demonstration, it does not diagnose or replace professional medical consultation. Thank you for your attention.